Hey guys, I just wanted to go over the next portion of bonding. It's called double bonding or multiple covalent bonding. Now, single bond is where you have two electrons or a pair of electrons shared between two nonmetal atoms. In this case, a double bond is just two single bonds put together. So a double bond, covalent bond, or simply a double bond is a covalently bond in which two pairs of electrons are shared between two atoms. Okay. Now, when drawing these Lewis structures, begin by connecting all with a single bond. All right, that's an important little tip that can help you out. And then make sure each nonmetal has 8 electrons. If not, make another bond using electron dots, forming a double bond. So, in conclusion, your final molecule, when it's done, each nonmetal except for hydrogen should have 8 valence electrons around it in some fashion. Okay, so let's take a look at these drawings I would like to do with you guys. The first one is O2. Let me get my pen out here. All right, so let's draw our Lewis dots of oxygen. Oops, that's a weirdo. 1, 2, 3, 4, 5, 6. Okay, we have the 2 at the top, 2 at the left, single, single. Now it only has 6 valence electrons. Let's draw our other oxygen. 1, 2, 3, 4. Okay, but in this case, instead of doing 5, 6, I'm going to do 5, 6. That way we have the open spots facing the other atom's open spot. Now, first thing you want to do is make a single bond. Now, what is a single bond? A single bond is a sharing between two electrons. Now, remember, oxygen has 2 half-filled orbitals, so it's going to need 2 extra electrons. So essentially what happens is one bond forms, okay? So this oxygen here shares this 1 electron, and this oxygen here shares this 1 electron. Okay, but essentially by this oxygen grabbing this 1 electron, it gives us 7 valence electrons. Okay, still needs another one. So now it's going to form a second bond with this electron here, and it's now going to have 8 valence electrons. So essentially your molecule is going to be O, double bond O, with its lone pairs around it like so. Okay, just like that. Okay, so no single bond, there's a double bond. So around this molecule, I'm going to change the pen color and do blue. Around the left oxygen, there's 2, 4, 6, 8 electrons. Around the right one, there's also 2, 4, 6, 8. And remember, a double bond is actually 4 electrons. Okay, so there's 4 electrons here, 4 here, so it's 8. So the total valence electrons 8 for each nonmetal atom, so therefore it's good. Okay, now CO2. Alright, so pen, let's draw a carbon. Carbon has 1, 2, 3, 4 dots. Oxygen, put 1 here and 1 here. Okay, oxygen has 6. 1, 2, 3, 4, 5, 6. Now I'm going to draw the oxygen like how I drew the oxygen in the first drawing. Okay, I'm not going to put 5 and 5 and 6 here. I'm going to put it here. Okay, that way the open spots are facing it. Now, currently this has 6 valence electrons, this has 4, and this has 6. Not enough, they all need 8. So we're going to start by forming a single bond to each one, like so. Now carbon shares 1 electron with this oxygen and 1 electron with this oxygen, so that makes it 6. But still, that's not enough. Okay, this oxygen shares the 1 with that, making it 7. And this oxygen shares this one here, which makes this one 7. Not enough. So we're going to have to make another bond right there. Okay, now carbon has 4 and 2 from here and 2 from here. So now carbon's got 8. Oxygen has 6 and shares the 2 with carbon, making that 8. And now this has 8. So they all have 8 valence electrons. Now, when it looks like when it's finished is O double bond C, double bond O with the 4 unbonded electrons or lone pairs around the oxygen like that. Okay, that's a double bond. Okay, so O double bond C, double bond O. Now for the next drawing, C2H4, okay, this one's a little bigger. There's 4 H's, 2 C's. Okay, so we're going to have our 2 carbons. They each have 4 dots. Okay, remember carbons are always going to be our central atoms. So we're going to put the hydrogens around the outside, like so. Because hydrogens are always going to be a terminal element on a molecule. So start connecting by a single bond. Okay. This carbon has 4, and now it gets the 5th from here. This carbon has 4, it gets the 5th from there. Okay. So now what we're going to do is we're going to bond this to here, this one to here, this one to here, and this one to here. They're all connected by one single bond. Okay, problem is carbon only has 5 valence electrons. When it's bonded to this carbon, 6 and 7 with those. So right now carbon only has 7 valence electrons. Therefore, we have to make a double bond there, which makes it 8. Okay, so it's going to be C, double bond C, bond, bond, H, 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 H. Okay, now around each carbon, there's 8 electrons. So let's change the pen color. Okay, around this carbon, there's 8 electrons. Around this carbon, there's 8 electrons. So we're set. Okay, so you can see that here's the original 4 from the carbon, and it gets it's 5th, 6th, 7th, and 8th. Okay, so this carbon has 8, and this carbon also has 8 as well. Okay. Now let's look at CH2O. This is known as formaldehyde. Okay. So we're going to start out with our carbon. Carbon has 4 dots. And then we're going to need an O in there. And I'm going to make the oxygen, the lone pairs, or I'm sorry, the single electrons facing the carbon. And I'm going to put the hydrogens over here, spread them out, and we're going to build it. Okay, so how does this work? Well, carbon has 4, oxygen needs 6, so all nonmetals except for hydrogen need 8, so there's going to have to be some kind of bonding here going on. So carbon shares 1 electron of hydrogen, making it 5. To the second hydrogen makes it 6. And then a single bond to the oxygen makes it 7. Okay, but that's not enough. So we're going to have to go another bond right there. Okay, So we're going to have C, double bond, O, and H. Okay, and our Lewis dots there, like so. That's formaldehyde. One side's very negative. Okay, so let's change the pen color. Let's go blue. Around the oxygen, there's 2, 4, 6, 8 electrons, and around the carbon, there's 2, 4, 6, 8 electrons. So there's a total of 8 valence electrons around the nonmetals except for hydrogen. Okay, so that concludes the double bond.